Hello viewers, I welcome you all this session on train resistances and tractive power. This is part of our railway engineering and transportation 2. I am Ashok Kumar, Assistant Professor at Department of Civil Engineering, Walchand Institute of Technology, Solapur. Learning outcome of the today's session, at the end of the session, students will be able to calculate the various train resistances and hauling capacity of a locomotive. So first of all, before we go into the various resistances, let us understand the various terminologies used in this railway engineering. Locomotive is nothing but it's the engine, it's a machine which transfers the chemical energy into fuel, into mechanical energy of motion. So it may be water, coal or diesel, electricity. So if you are using a diesel, it's a diesel locomotive, or it is electricity locomotive, or it is a steam, so steam locomotive. So now in Indian Railways, usually we use diesel and electric locomotive. In earlier days, we used to go with steam locomotives. So next one, hauling capacity. So what is the hauling capacity? It is the total load coming on the driving wheels. We know that there is a driving wheels and non-driving wheels in the locomotive. So total load coming on the driving wheels, or it is a load which can be dragged or pulled by it. So how you calculate the load coming on the driving wheels or hauling capacity? So it's nothing but like a person weighs 60 kg or 80 kg. So that is the capacity of a particular person. So like this, for engine also has got a particular capacity to take the load on driving wheels. So that is called as a hauling capacity. Here hauling capacity is calculated using mu into W into N, or in like F into W into N, where mu indicates the coefficient of friction between the wheel and rail. W is the weight of the driving wheel, and N is the number of the pairs. So if you know the total, the number of pairs and weight coming on the driving wheel and coefficient friction, you can calculate what is the hauling capacity of a locomotive. Another terminology is like a traction. So traction is where we get the source of energy for this locomotive. Either you are using a diesel, it means you are getting a source from the diesel. You are getting a fuel as a source, as a fuel. Electricity or a coal, that is called as a traction, the source of energy. Then tractive effort is the propulsive force of the locomotive, or the forward thrust given by the locomotive. So taking this all resistances, the engine should go forward, or locomotive should go forward. So that is the tractive effort is equal to greater than the hauling capacity. So whatever the load coming on your driving wheels, that is called as the hauling capacity. So you should try to keep this tractive effort more than the hauling capacity. Then only I can take the particular load in a forward direction. Tractive resistance is the force which resists the forward movement and speed of the train, are called as tractive resistances. We will try to discuss this in detail, because in this tractive resistances we have so many resistances which forces which resist the forward movement of the locomotive. So under this, we know that whenever we are trying to go on the rail, we come across the various the resistances. It may be due to the internal component parts, maybe like a friction, or it may be friction between the tire and the rail surface, or it may be due to the curvature of a particular area, or it is due to the gradient also, or it is due to the acceleration and deceleration of the vehicle also. So we will have this various train resistances. So when you are trying to fix the capacity of an locomotive, you try to keep this train resistance into the consideration. Otherwise, you cannot pull any particular load beyond, because when the train resistance is more than the power of the engine. So we should try to keep it in mind. So our capacity of an engine or locomotive will be more than the train resistances. So these train resistances are classified into 4 categories. One is the train resistances, resistance due to the track profile, or resistance due to the starting and acceleration, and wind resistances. The first one, we will go to the discussion of the train resistances, how it is going to have the resistance of the locomotive. Under this, we have independent of speed and dependent on speed, and atmospheric resistance also. This train independent of speed is mainly due to the friction. It is friction. We have general friction, frictional resistance, and it is due to the internal parts. So this component will have a resistance inside the component, like your bearings or between the component. This offers the resistances. So independent of speed is mainly due to the friction. So this is called as the RT1. And yeah, it depends upon the type of the bearing you have used, or have you maintained the properly vehicle on a condition, a lubricant is used, or and depend upon the temperature also. So this is called as the independent of speed, and it is given by 0.0016 into W, where W is the weight of the train in tons. Next one, dependent on speed, RT2. Here it is mainly due to the poor maintenance of the track. Here the track is not properly maintained due to the irregularities, like whenever you come across. So there is a train is trying to, due to the poor maintenance, so you may see that zigzag movement of rails. So this is like, it has got many reasons, mainly poor maintenance or high axle load, properly not constructed that track, the material quality, temperature. So this is because of this, the rails will bend like this also. So due to the flange friction, oscillation, swaying, so there is a chances of even going for a derailment also. So in this condition, it is given RT2 as 4 times 0, 8 W into V, where W is again, it is the weight of the train in tons, and V is the speed of the vehicle in kmph. Now the wind resistance. So we have wind resistance in two directions. One helps in a forward movement, another opposes the motion. So we have to consider this wind resistance, but is at what angle it going to impinges the train. That is very, very important. So that when we know the speed of the wind and the angle, so that we can calculate what is the train resistances on the forward movement as well as on the opposite the movement. So it is given by 4 times 0.17 AV square, and A indicates the exposed area of the train in square meter, and V is the speed of the wind in kmph. Now you pause over the here, think for a moment where you can see there the your speed, wind speed is coming with a certain angle, that is a theta is the angle. Can you calculate these components? One in the opposing the movement, because train is going in this direction. So train is going in this direction. So what is the component of this opposing movement, and what is the perpendicular component of this velocity of a wind? So I hope you are able to write the answer. The correct answers are V sin theta is the perpendicular of, if I resolve this, the inclined wind velocity, V sin theta is the perpendicular component, and V cos theta is the opposite movement, which has the, when train is moving, it is going to have the force of V cos theta. Next one is atmospheric resistance. So here we have again it is considered as the ends and sides of the train. So it depends upon the square of the velocity of the speed. So it is given by again 6 zeros, 6 WV square. Again V indicates here not the speed of the wind, here it is a V indicates the speed of the train in kmph, and again W is the weight of the train in tons. So total train resistance RT1, it is given as RT1, 2 and 3. It is independent of speed, dependent on speed, and atmospheric resistance. Next one is a resistance due to the track profile. So if you are traveling on a particular slope, like a gradient, like you are traveling on a particular slope like this, so your vehicle is going to travel on this, on a particular, you are going for a on a gradient like this. So having a theta, this is the theta, this is the theta. Now what is this train resistances? Train resistance due to this the gradient theta or a slope. So that is given by W into G. Here it is a weight of the vehicle acting downward, and G is nothing but the slope. So if it is a given slope is like a 2% and the weight is given as a 2 ton, I can calculate this the train resistances due to this gradient. It is given by W into G. So here this theta has got some resistance. So when you are vehicle traveling on the gradient, it has to negotiate certain resistance. So you need a extra tractive force when you are negotiating on a particular this gradient. So that comes to it is a G value is taken as in percentage. It is W into percentage, that is W into G or slope. So 2 divided by 100, that gives multiplied by the weight, that gives 40 kg is the resistance due to the this gradient. Next one, it is due to the curvature. Now, you can think that due to the rigidity of the vehicle wheelbase, the vehicle cannot adapt itself to a curved track, because the vehicle is coming from this straight, and suddenly you introduce the curvature like a 2-degree curve or 3-degree curve. So, still the vehicle has a movement in this forward direction only. So, it is now you are going to turn with a certain radius or certain degree. So, in this condition, due to the rigidity, it is still it wants to go into this tangential direction of the curve only. So, because of this, so there is a the rubbing of a flange of outer wheel of the leading axle and rubs against the inner face of the outer. So, there is some rubbing force happens between the leading axle as well as even the in the rear axle also there is a rubbing happens. So, due to this, there is extra energy you required to negotiate this particular curvature. So, depending upon the type of the gauges, they have suggested the equation. For broad gauge, it is 0.0004 W into D, and for meter gauge and narrow gauge, depending upon the width of the gauge, we can adopt this formula to calculate this train resistance due to the curvature. If I give you 50-ton weight of the train and a 4-degree curve for a broad gauge, we can for it is meter gauge, we have used 0.003 into weight of the vehicle and degree of the curve. So, that comes 60 kg is the resistance due to the curvature. Now, again resistance due to the starting and acceleration. So, whenever vehicle is going to have a starting, there is some resistance offered by the during starting of the vehicle. It is given by 0.005 into W2 and 0.15 into W1. So, total of the total resistance due to the starting, it is given by 0.15 W1 plus 0.005 W2. It is where W1 is the weight of the locomotive and W2 is the weight of the vehicle in tons. And due to the acceleration, again the equation is suggested 0.028 W. During acceleration also some resistance is offered, V2 minus V1, where V1 is speed in kmph at the beginning of the acceleration, and V2 speed of the vehicle in kmph at the end of the acceleration. So, if you take out that difference, that comes to V2 minus V1. And A is acceleration in kmph per second, and W is the weight of the train in tons. So, total resistance, it is RT1, RT2 plus RT3 and RT, that is resistance due to the starting and acceleration. So, these are the references I have used for preparing this presentation. Thank you.